The distribution of temperature across the globe is influenced by several factors that determine climate patterns, weather conditions, and regional temperature variations. Some of the key factors include latitude. Insolation depends on latitude, transparency of the atmosphere, length of the day. Effect. The amount of solar energy received at different latitudes varies. Near the equator, low latitudes, the sun's rays are more direct, resulting in higher temperatures. At higher latitudes, towards the poles, the sun's rays are more spread out, causing lower temperatures. Explanation. The Earth is tilted on its axis, and as a result, regions near the equator receive more consistent sunlight year-round, leading to warmer temperatures. Polar regions receive sunlight at a lower angle, spreading the energy over a larger area and leading to colder temperatures. Altitude, elevation. Effect. With increase in altitude, temperature decrease at normal lapse rate. Higher altitudes generally experience cooler temperatures. Explanation. As you move higher above sea level, the atmosphere becomes thinner and air pressure decreases, which leads to lower temperatures. This is why mountains and highlands are often cooler than lowland areas, even in tropical regions. Proximity to oceans and large water bodies. Effect. Coastal regions tend to have milder and more moderate temperatures compared to inland areas. Explanation. Earth behaves differently depending on specific heat of the surface. The land surface with lower specific heat, land heats up rapidly and cools down rapidly. Water has a high specific heat capacity, meaning it takes longer to heat up and cool down compared to land. As a result, coastal areas experience smaller temperature fluctuations, whereas landlocked regions experience more extreme seasonal variations. Ocean currents. Effect. Ocean currents redistribute heat around the planet, influencing regional climates and temperatures. Explanation. Warm currents, like the Gulf Stream, raise temperatures along the coasts they pass, while cold currents, like the California current, have a cooling effect. These currents help moderate temperatures in nearby land areas and contribute to more consistent climate patterns. Prevailing winds. Effect. Winds can transport air masses and moisture across large distances, affecting regional temperatures. Explanation. Winds from the ocean, such as sea breezes, can bring cooler, moist air inland, moderating temperatures. Winds from land, like land breezes, tend to bring drier and warmer air. Winds also carry warm or cold air masses, influencing temperature patterns. Distribution of continents. Northern hemisphere with large extent of continent than ocean experience high range of temperature than southern hemisphere where water surface is more. Topography, landforms. Effect. Mountains, valleys, and other landforms can create temperature variations. Explanation. Mountains can block or redirect wind and air masses, affecting temperatures on either side, a phenomenon known as the rain-shadow effect. On the windward side of mountains, air rises and cools, causing precipitation. On the leeward side, the air descends, warms up, and results in drier and warmer conditions. Seasonal changes and the Earth's tilt. Effect. The Earth's axial tilt causes seasonal variations in temperature. Explanation. The tilt of the Earth's axis means that different regions receive varying amounts of sunlight throughout the year. For example, summer occurs in the northern hemisphere when it is tilted toward the sun, and winter occurs when it is tilted away. This axial tilt results in seasonal temperature changes in temperate and polar regions. Cloud cover and albedo effect. Effect. Clouds can either cool or warm an area depending on their type, density, and altitude. Explanation. Clouds reflect sunlight, reducing the amount of heat that reaches the Earth's surface, or trap heat, acting like a blanket. Dark surfaces like oceans or forests absorb more heat, while light-colored surfaces like ice or deserts reflect more sunlight, contributing to the albedo effect. Human activity. Effect. Human activities, such as deforestation, urbanization, and greenhouse gas emissions, can impact local and global temperature patterns. Explanation. Urban areas, urban heat islands, often experience higher temperatures due to concrete, asphalt, and human-made structures that absorb and retain heat. Greenhouse gases trap heat in the atmosphere, contributing to global warming and altering the global temperature distribution. Volcanic activity. Effect. Volcanic eruptions can influence temperature by releasing gases and particles into the atmosphere. Explanation. Large eruptions release sulfur dioxide and ash into the stratosphere, which can reflect sunlight and cause temporary global cooling. This can affect regional and global temperatures for months or even years. These factors, in combination, determine the complex patterns of temperature variation across the globe, resulting in the diverse climates we experience in different regions.